The Protofoil system is a personal and small group electronic file cabinet for the knowledge worker. In this system, we have focused research on new techniques for dealing with the two ends of the process where the user interacts with the system: document entry and document access. On the document entry end, we use paper user interface technology to reduce the time costs for entering a document. On the document access end, we built a workstation interface that supports a multitude of search and browsing techniques to richly facilitate finding and using documents in the file cabinet. Paper user interface technology allows using cover sheets to input paper documents. Using this typical Protofoil form customized by one of the system's users, the user can input a document and assign a category by filling in checkboxes, or instruct the system to perform other actions on the document, like distribute via fax or email to other people, or specify hints to the system. The system processes this form by first recognizing which form it is by reading digital data encoded as glyphs. Then, it determines which areas have been marked on the form. Finally, it invokes appropriate document processing functions. With Protofoil forms, the document is stored along with an attribute value description that contains categories, scan date, and other fields for the document. The text of the document is also extracted using OCR on the scanned images and indexed using the TDB full text database system. Once documents have been stored in a Protofoil document database, users can find them using a workstation user interface. By providing a variety of search, automatic classification, and browsing mechanisms, we have reduced the upfront cognitive overheads of categorizing documents at filing time. The interface is based on a tiled pane layout with 3 columns, a thin strip containing tools which can be invoked or applied to particular documents, a middle column for specifying queries and browsing results, and the right column for browsing individual documents and editing their attributes. The interface is controlled using pointer gestures and keyboard commands. Document retrieval in the Protofoil application is based on an iterative loop in which 4 user actions are variously interleaved: selecting a scope, initially the entire file cabinet, specifying a query, browsing results, and browsing and utilizing documents. A Protofoil query can use a variety of Boolean and textual search techniques, singly or in combination. In particular, 5 search techniques are currently supported. First, a search on category names. Categories can be assigned at scan time using the paper user interface or later using this interface. Note, an appropriate view based on the search technique used is automatically selected. In this case, the category view, which shows matching categories and the number of documents in the category, has been selected. The scope of subsequent queries can be restricted to categories. The documents of the category can be browsed by using the click gesture. The second kind of search is on attributes associated with the document, including title, keywords, and scan date. The third kind of search is a ranking similarity search provided by the TDB system developed at PARC on the textual content of the documents as extracted using OCR. This search automatically selects a list view which shows scoring information, number of pages, category and identifier information, and matching document terms. The fourth kind of search is a similarity search based on a previously found document. This style of interaction is called relevance feedback in the information retrieval community. And finally, the fifth technique is a textual proximity search, which looks for documents which contain a set of words within an n-word span in the document. This technique is also supported by the TDB system. The view automatically selected for the proximity search is a keyword in context display developed by Cutting, Pedersen, and Tukey. This view shows documents and matching locations within each document displayed as snippets. The search terms are shown in the context of their use by guttering along the nearest meaningful non-search term to facilitate rapid assessment of each location by reading down the so-called gutter. Though appropriate views are selected automatically based on the chosen search technique, other views can also be used. So for example, this result can be viewed in 5 ways. The thumbnail view shows reduced images of the document's first pages. It is quite effective for picking out the genre of the document. For example, this is a memo, this is a memo, this is an agreement, this is a Lexis search printout, and this is an article from a book. The list view shows various attributes of the document, including page count and category. As we saw earlier, scoring and matching terms are shown as well for similarity search. The category view groups the document by categories. The cluster view groups the document based on a statistical analysis of their OCR text. The clusters are described by showing their central terms and a few central documents within each cluster. In this case, the 5 documents are clustered into 5 clusters. This view is more useful for larger result sets. And finally, the snippet view. Once documents are found, a variety of operations can be performed on them. They can be placed in the holding area for later processing, be dropped on document tools like print or fax, or be flicked into the similar to pane for another search. Documents can be browsed using the document browser on the right side. Their attributes can be edited. 4 views of the document are supported. This view is appropriate for full page screen viewing. The pages of the documents can be flipped through. Document page images can also be viewed at 2 higher levels of reduction. And finally, the OCR text of the document can be viewed. When a user selects a snippet, the document browser automatically uses the text view and highlights the location of the snippet within the document. To illustrate the use of scoping and clustering, we show an iterative usage pattern designed by Cutting, Karger, and Pedersen called scatter-gather. The first step is to scatter the entire file cabinet into a set of clusters. To do this, we invoke an empty search into the cluster view. We then gather one or more of these clusters as a scope for another cycle of search, which means that only documents in those clusters will be retrieved. Then by searching again with an empty query, the system scatters the items into another set of clusters. More than one cluster may be added to the scope. The scatter-gather loop is only one retrieval interaction pattern supported by Protofoil. The multitude of search techniques and of result browsing views, along with the operation of setting scope, offer a rich set of tools for locating documents without requiring upfront classification or keyword assignment.